Plato, up next, the latest in fat. And we're talking good fat here. Now, those of you who have tended to babies may have you've heard the term brown fat. That's the name of a type of fat that keeps infants and babies warm. And rather than storing calories, brown fat actually burns calories and produces heat. And scientists have long thought that brown fat disappeared by the time these babies became adults. Turns out they were wrong. This week, researchers are reporting that they have found active brown fat in adult humans, and that fat might play a role in obesity and regulating glucose levels. Joining me now to talk more about this good fat is my guest, C. Ronald Kahn. He is the Iacocca Professor of Medicine at Harvard Medical School and the Joslin Diabetes Center in Boston. Welcome back to Science Friday, Dr. Kahn.
Thank you, Ira.
How come we never knew about this stuff?
Well, I think that people had thought that brown fat, at least in adult humans, was only going to be present in some extraordinary circumstance. For example, it was known that people who had a disease of the adrenal glands, a tumor called pheochromocytoma, would have more brown fat. And people also knew that people working in the northern part of Finland and outside in the cold had some brown fat. But people thought this was the extraordinary, unusual example and that normal people didn't have it. But obviously our article and the other two that were in the New England Journal this week have shown that that's not the case.
Is the fat really brown-colored?
It is indeed really brown-colored. You know, most of the fat in our body is white or slightly off-white and yellowish because it's full of lipid. It's full of triglyceride because that's where we store the energy from the food we eat. When we don't have access to food, we can burn up our fat. But brown fat doesn't have very much stored lipid, not much triglyceride. Instead, it's filled up with mitochondria. Mitochondria are those little parts of the cell that are important for burning energy. So this fat burns energy rather than stores energy.
Huh. And is that why we have it, so we make the energy from the fat?
Well, the reason that at least little babies have it and also some rodents have it is that it's used to create warmth. So as it burns up energy, it actually creates warmth. As we get bigger, it's less important in keeping warm. We have other ways to keep warm, like we shiver and we have sort of some insulation by the white fat in our bodies. So I'm not sure that in adults its major reason is for warmth, but I do think it plays a big role in keeping this energy balance between storage and burning.
So now that we've discovered that we have the brown fat, does that mean that when we get really cold, we can lose weight?
Well, that's a great question, and of course we don't know for sure the answer. What we do know is that people who are exposed to the cold for even 2 hours, or when we did our study, people in the winter versus the summer have definitely both more brown fat and more brown fat that's in an active state. So I think one of the questions that we really need to look at is, could we take advantage of this as a way to kind of naturally stimulate this energy burning?
Aren't you going to see people now outside with no jackets on after hearing this?
Well, maybe we will. I think that there may also be, some genetic differences in how we respond to this cold treatment. But I think, of course, the thing about obesity is that there's so many factors that contribute, not only how much we might burn through brown fat, but, of course, how much we eat and how much we burn through exercise.
Is there a way to tell how much an individual, you yourself, have brown fat?
The techniques that were used in the studies in these three papers are really pretty involved techniques. They would only be used in a really major clinical setting. The techniques are called PET-CT, and it's really the combination of two techniques. The one technique, CT, is computerized tomography, and that helps us tell the difference between fat and muscle and bone and other kinds of tissues. And the other technique, which is called PET, stands for positron emission tomography, really involves giving a kind of radioactive glucose tracer to see what tissues are most metabolically active.
Yeah.
And when we do this, we say, well, if this fat is highly active, it's likely brown fat. And sure enough, when we biopsied it and when the other groups biopsied it, it was brown fat.
Let's go to the questions. Tony in St. Louis. Hi, Tony.
Good day. Question about are there differences in things like omega-3s versus omega-6s as there seems to be in other creatures like tilapia, which farm raised are greater omega 6, and
You mean
wild
in
raised
our
are
own
greater
brown
omega 3s.
in our brown fat? You mean stored there? Good question, Dr. Kahn.
Well, we don't know exactly how dietary fats will modify either the amount or the activity of brown fat. We do know that some of the radiologists who are trying to interpret these PET CT scans for cancer purposes find that the presence of brown fat kind of a distraction. It misleads the diagnosis. And so they actually do give people sometimes a high-fat diet, which actually seems to turn down the activity of the brown fat.
Mm-hmm. I would imagine then if brown fat causes you to lose calories, that you would find more of it in thinner people. Is that correct?
That is correct, and that's exactly what we found, and actually what one of the other studies found. That is, the people who have the lower BMIs tend to have the more functional, active brown fat.
Mm-hmm. So and of course, people are going to say now, "Hey, what can I do to stimulate my body to make more brown?"